Hello everyone, in this video we're going to be talking about the component form and the magnitude of the vector. So first I need to talk about what is the component form. The component form is just writing it as v1, v2, so we're just going to be subtracting the two values there to find out the actual component form. So let's just make a little note, this is the component form. Okay, so now let's move on. The initial point is 4, -7. So what we're going to do is we're going to label these as P1, P2. Okay, so let's write it out. 4, -7. So this is P1 and this is P2. And then let's also write out the terminal point, which is -1, 5. And that's going to be Q1, Q2. Okay, so now we can write out our component form. It's going to be Q1 minus P1, comma Q2 minus P2. So let's do our component form. We're going to do Q1 minus P1. So V is going to equal, our vector is going to equal Q1 minus P1, comma Q2 minus P2. All right, so now we're just going to simplify this. 1 minus 4 is going to be -5, or sorry, -1 minus 4. And then 5 minus -7, that's really 5 plus 7, which is going to be 12. All right, so this is our V1 and our V2 in our vector, if you want to label that. All right, so this is one of the things that the problem is asking. And we now need to find the magnitude of our vector. So remember, the magnitude is sort of like a distance formula. You can either do Q1 minus P1 squared plus Q2 minus P2 squared, or you can just say V1 squared plus V2 squared and the square root of that. So let's just take this route here. So we're going to find the magnitude of V. So that's going to be the square root of V1 plus V2, which is -5 squared plus 12 squared, and all of that under the square root. So we're just going to simplify this now. So let's go type this into a program and figure out what this is equal to. Or we can just do it here. -5 squared, that's going to be +25. 12 squared is 144. So this is going to be the square root of 25 plus 144. That is going to be the square root of 169. And I believe that is 13, but let's just go double check. Yes, that's going to be 13. All right, so the magnitude of our vector is going to be 13. All right, let's try out another problem. First, let's write it in the component form, and before we do that, I do want to go ahead and label the points that we have. So initial point is -1, -2. That's P1, P2. And then we have our terminal point, which is 7, 3. So this is going to be Q1, Q2. All right, so let's find our component form first. V equals Q1 minus P1, so 7 minus -1, okay, comma Q2 minus P2, so 3 minus -2. All right, and we're just going to simplify this. So 7 minus -1, that's really 7 plus 1, which is going to be 8. And then 3 minus -2, that's really 3 plus 2, so this is going to be 5. This is V1, this is V2. So now that we have our component form, our magnitude is going to be a little bit easier because we can just square V1 and V2. So let's do the magnitude. It's going to be the square root of V1 squared plus V2 squared. 8 squared, that's going to give us 64. 5 squared, that's going to give us 25. Okay, so 64 plus 25, that is going to give us 89. Okay, and the square root of 89, it can't reduce because 89, that is a prime number, so it's not going to have any factors there. So the magnitude of our vector is going to be the square root of 89. All right, I hope that you guys enjoyed this video. Please stay tuned for the next one where we talk about vector addition and scalar multiplication. Goodbye.